Hey everybody, welcome back to the shop. Today I've got a little repair I've got to do. This is a cartridge that goes in our Jenn Aire oven. It's a slide-in oven with downdraft, and Jenn Aire has made that model for, or a version of that design for quite a few years. This looks like heck. This will clean up with normal cleaning a little bit better than what you're seeing right now. I decided not to bother cleaning it since I just took it. We just had it fail. The small burner was working, and then all of a sudden it just stopped working completely. The food we were cooking on it started to cool off, and we couldn't get it to come back on. So the next day we were using the larger burner, and actually it was just this morning, and the larger burner then failed. I was worried initially that there might be a problem in the actual control circuitry in the stove itself, but the way that the stove comes when you buy it is it comes with one of these cooking cartridges with two burners on one side, and it comes with these inserts, which are just it's just an element, a heating element that sits over these fake they're cast iron plates that are fashioned to look a little bit like coals, and what you end up with is grills on the top. So you end up with a griddle on one side or a grill on one side for indoor grilling, but you can take those out and you can buy a second one of these and you can have a more traditional 4-burner top. I was able to swap this cartridge out to the other side, and when I swapped it out to the other side it still didn't work, but the grill works. And when I took the grilling element out and stuck the element in on the side that this came out of, the element worked, which tells me it's not a control problem in the stove. It's definitely the problem is contained to this unit. This was originally all white like this, and this coating has failed over the years. The nice thing about it, though, is that what's underneath is actually a brushed stainless steel finish. So this actually, you know, if you didn't see all of this, you might think that this is how this actually came, that it's supposed to look like this. And the rest of the top of the stove is stainless steel. So the plan is, if I can get this repaired, or I should say, if I can repair this, I'm going to remove what's left of this white and leave just the brushed stainless look. And then we'll try and clean this glass better. But first things first, find out whether or not we can actually fix this unit. So in order to open this up, there are 1/4-inch screws on the side here. So I got a 1/4-inch nut driver, but I just wanted to mention before I open this up, we got a surprise waiting for us inside, because that doesn't sound right at all. So I've removed those 7 screws. There is a screw right here. It's pretty badly corroded, but I'm willing to bet that that screw is probably responsible for keeping this plug assembly in position here. So I think if I flip this back over, top side facing up, I might be able to actually pull that whole top assembly off now. Can't quite tell whether or not it's just stuck from probably never being apart in its life or what. A little bit of a popping sound when I pried up on it. There we go. I think we're on the right track now, I believe. Yeah, we got a little bit of a train wreck in there. Okay, let's turn this over. It's all corrosion falling out of there. Wow. Well, there's the mystery. Solved. Oops, I just knocked this out. Not sure where it went. These are just in here loose. That can't be good. Give you a close-up of this. Get a load of this. Everything's just loose, moving around in here. Several of these clips are just floating around in here. They look like they were originally, by the looks of that hole, I'd say these were originally riveted in place. They probably had the job
of keeping these in position from being able to just float around and move around. So I'd say each one of these little holes right here originally probably had a rivet. And these probably went just like this. Yeah, you can actually see there's almost a bend there to them. Interesting. So it looks like this is not bonded to the glass. It looks like it's just, when it's in its proper position, it's directly underneath. The glass is basically going to be pushing right down on this insulating material right here. That heat's going to be trapped in this little well, and the glass acts like a cap. There's a lot of rust and debris in here now. It fell in there. Alright, I think what I'm going to do is I'm going to take these elements out and do an electrical continuity test on them and a resistance check. So I just wanted to, actually don't have to unplug this to do a continuity check, since it's the cartridge is removed from the stove. There's nothing really in the circuit other than the element itself, or I should say the element assembly. So let me point out something about the design of this thing, and this is something that I've always not liked about the way this stovetop works. When the stove is put on high, full voltage is sent to the element here, and the element will heat up and get very hot, so hot that you can actually see red through the glass. Okay, and what happens is, if it gets to a certain temperature inside here, this little tube right here, okay, which is covered in glass, it's a metal rod covered in glass. This tube right here will actually detect the heat, and when the heat gets to a certain preset limit, there's probably some sort of fluid or something inside that tube that expands and will actuate a switch over here in this little module and shut the power off to the element. So in other words, you're calling for full heat, it's on high, the voltage continues to come in at the plug, but this little assembly right here, this tube and this little box, are going to act as the regulators to keep the heat from being able to get too high. But I always felt, it seemed to me like the thing would always cycle off prematurely. And the end result is it just takes forever to boil water on this stove. If you've got a big pot on there, like for sweet corn, for instance, it just takes an inordinate amount of time. Inordinate? What did I just say? It just takes way too long to reach temperature, boiling water, in my opinion. Of course, I was used to the good old days when we were in a little old apartment and had a gas and gas stove, and you can't beat gas for cooking on the cooktop. But we don't have natural gas here, so the best we could hope for is propane. And if we wanted to add a propane stove now, propane stovetop now, I'd actually have to have a propane company come in and install the tank and the lines and everything. So that would be a bigger expense and project than we want to do at this time. When I was building the house, if I could start all over again, make the decision all over again, I think we probably would have opted for the extra expense of propane. And we may have even put it in a large underground propane tank and went with a propane-fired burner in our boiler instead of the oil-sucking boiler that you hear firing up in the background right now. Okay, so let's check what the resistance is here. Now, with this cold, this switch, which is probably an electromechanical device, should be in the closed position. So if I look at the way the wires come in here, I could see that this is one of the power leads right here. It comes right to this box on this side, and the other power lead comes in over here on this side. So this power lead goes directly to one of the two connections on the element. So these two connections right here are to the element itself. So we got power coming in, goes through the element, comes out, goes into the switch in here, comes out of the switch and goes back. So we have a series circuit that's happening here. So first check I can make real quick, I can go right across the element, right here and here, and I can look and see what we've got for resistance. Making sure my meter is in fact working, and it is. I'm going to put this here. I don't know if the glare is going to show this, okay, but you see if I short the leads, I get almost 0 ohms. If I go right across here and here, notice it stays OL, which means the resistance is very, very, very high. Infinite resistance, or out of limit, however you want to say it. So this element is open. Let's go over here and check what's going on with this. Notice 0 resistance, meaning the switch is closed. And as far as I can tell, that would indicate that this is okay. Now, just because it's closed when it's cold now doesn't mean that it's opening at the right temperature. If it starts opening at a lower temperature than what it's designed to open at, well then of course you're going to have a problem with this not getting hot enough. It's rated for 10 amps at 250 volts, but it does not appear to be showing, well, it does say T250. It says 7/400, and then it's got almost like the AC symbol, T250. I don't know. That might be a mystery as to what the actual open temperature, the temperature that's designed to open at. So this element's bad. Same design. Here's the power going into the actual element. Switch is probably fine. It is. Let's see what's going on with this element. Oh my. Well, that element unfortunately is also wide open. So it's cooked. So once you've determined that your burner is open, then it's just a matter of getting a replacement burner. Now, apparently the original manufacturer of these ovens is Whirlpool, because a lot of the parts come branded Whirlpool. Jenn Aire is like a higher end, or at least it was considered a higher end brand, so you tended to pay a little more money for the oven branded as Jenn Aire, for instance, than you would if it was just branded as a plain Whirlpool. And then also it may have been branded as Kenmore if it was sold through Sears, because Kenmore had an agreement that a lot of their appliances were made by Whirlpool. Anyways, you can still buy these replacement elements. These are, I believe they're referred to as burner elements for smooth cooktops. So even the non-cartridge ones, like I've got with the cartridges, but the ones that just have like a glass top across the whole top of the oven, apparently they use the same technology, this type of burner. And I was able to find these online. They go by size of the burner. I think somewhere on here I also mentioned already that there was a wattage rating. I think it was on the cartridge. But you just measure the diameter of these, and you can order replacements and drop them in if your pan is in good condition. Now my pan, the problem is that I've got all of that corrosion in there, and all of the little the little metal spring clips that are supposed to hold these in position are popped off. So I've got to do something about that. You can find people selling like a used one of these on eBay and wanting as much as $30 for a used one, but that would be a mistake to buy it that way when you can go and just search Whirlpool smooth burner, and you'll start finding a bunch of results where you can buy aftermarket replacements of these burners. Brand new, I found them for as little as $33 for a brand new one. Maybe a little bit more for the larger one. But, as luck would have it, years ago I wanted a second burner cartridge for that oven. And I ended up finding one on eBay that was really reasonably priced, and I bought it and I made a mistake. I never ended up returning it because it was my fault, and I got a really good deal on it anyways, and I thought, well, maybe I could even use it for parts. So what we have is a brand new old stock module, and oh, I remember what it was, what the problem was with this. This does say that it's a Whirlpool cooktop module, okay? But the problem is, not that the plugs are on the side, it's that it's a different plug altogether. That's why I can't use this, but it occurs to me that I might be able to use the burners out of this. It's not doing me any good, so I might as well pop it open. Looks like, I don't know if this is newer or older than the one I have. This one's got Phillips head screws instead of the 1/4 inch. Alright, so I just popped the cover off here. And it looks like we've got a horse of a different color. So this is interesting. This has got 2 burners of the same size instead of a small and a large. Also, the pan appears to be different. Appears to be deeper. And they've got these brackets that are supported by these screws here going across that actually hold these up into position. So it's a different design, unfortunately. But I'm not convinced that I might not be able to still use these. Alright, so the first thing I'm going to do is, I'm just going to satisfy my curiosity. I want to know what the resistance, what the electrical resistance in ohms is supposed to be of these elements. Now, these are brand new, so there's no reason why these should not give us some sort of a reading. Put that over here. I don't know if you're going to be able to see that or not, but take my word for it, that's 39 ohms. And this one's the same, 39 ohms. So, no surprise, these are good elements. If the pans were identical, then it might just be a matter of simply pulling this plug out. Only you see it's riveted in. Alright, so I'd have to drill out these rivets and change this plug. But even the opening where the plug goes looks like it's different. Alright, so now I've got the new burner removed next to the old burner, and first look, it looks like I'm going to be out of luck. First glance, it looks like I'm going to be out of luck. But turns out that this bracket that's on the bottom of this one actually just unscrews and can be removed. Once I remove this bracket, I already checked. The thickness from this area to the top here is 1¼ inches. It's actually the same as on this one. So the only thing that I'm going to have to worry about now, because the connections are the same, is the diameter. The diameter is just a little bit bigger, but I think there's going to be enough room in there to make this work. There is a sticker that says it's 240 volts, so I know I've got the correct voltage. Switch, the high limit switch, which that glass tube hooked up to this device here, that has the same exact rating and numbers on it as this other one over here, which is 240 volt 10 amp rating. But that's just the current rating of the contacts inside that high limit switch. I mean, it's a good sign that it's the same, but it doesn't prove anything. Silk screening on here that does indicate that this is, in fact, a 1400 watt element, 240 volt. And now with them lying side by side next to each other on the workbench, you can actually see that the height's the same. This is just a little bit larger in diameter, but this might actually be the diameter of the larger burner. I think this is the smaller one. Yeah, oddly enough, this burner is smaller than the larger burner. Took a few minutes to scrape out as much of the rust and corrosion and grease that I could, and this is a lot better looking than it was. So now that I've got all that out, I can take a look here and see. Well, looks like that's going to work just fine. Since these were all broken off when I opened this up, I have no idea how these were supposed to be in here. Alright, now I'm pretty confident exactly how this was mounted in here. These clips were mounted at these holes right here. Okay, And the clips do two things. The clips keep the side part right here, keeps the burner from being able to move around. And this part of the clip right here, this angled part right here, actually acts like a spring-loaded area to keep the burner pushed up tight against the underside of the glass. So when you first install these burners, they just kind of are floating in here. And as you reassemble this and push this top piece down in, it's going to push the burners down and they're going to compress this. And that's why they probably eventually failed when these rivets got rotted. So I've got to reattach these to the pan. That's no problem. I can just rivet them in. But if I rivet them in at the current position, they'll actually be too far apart from each other for this burner, because this burner is 7 inches in diameter, and the original one that went in this position is 7 3/4. So what I need to do is I need to relocate these clips so that when I move them in a little bit, I will end up with a 7-inch diameter circle that this drops into instead of 7 3/4. So I've got to basically take 3/4 off the diameter, and I got to take half on each side. So essentially what I'm going to end up doing is I'm going to end up moving in the position of these clips from their original position exactly half of 3/4, which would be 3/8. Then I'm just going to take a look at where these holes are now. That's unfortunate. That's going to cause a problem because the new hole location is going to be right on this little ledge here. But I might not be sunk just yet, because I could actually move this hole on the bracket further back. In other words, if I move this hole location on this bracket back, I can actually have the effect of moving these in a little bit. So a combination of maybe moving the hole location into the edge right here. It's actually easier to see it on the back here. So again, if I take my dividers, you can see that it's just going to be in the way there. I cleaned out these original holes so I could get the size of the rivets that were used originally. And I'm going to make new holes just close enough to this edge so that I could still fit the flange of the rivet in there, which looks to me like that's going to probably get me about 1/8 of an inch. And then I'm going to put new holes in these brackets again over right about here, and between picking up about 1/8 of an inch here and 1/8 of an inch here, I'm going to get about 2 of my 3/8 of an inch back. All right, so there's my 3 little mounts there repositioned. You can see the original holes, and I'm a little bit behind that on that one and that one and that one. That closes that whole diameter down, so that now hopefully this will sit fairly pleasantly in here. Yeah, it does. See? So what's going to happen is when I'll wire this all up, and then when I put the glass on top and I push down, this will compress down into here, and just like this, and stay in position. Won't be able to move around. Actually kind of stays down there now. Beautiful. The small burner is actually closer in size to these replacement ones. The small burner is 6 3/8, and these I said are 7, right? Right. So 5/8 of an inch difference in diameter, and half of 5/8
is 5/16. So I need to enlarge this circle by 5/16 of an inch in diameter. Alright, this one was a little easier. I didn't have to re-drill the brackets because I'm widening this circle, so I've got plenty of extra metal out there. Alright. Make sure that I got these connections are good. That's the general idea. Now we can get that glass straightened out. I wish I could use this brand new one off of the salvaged unit I just salvaged, but unfortunately it's not even the same length. So there's no way I can use this. Actually, if the glass is the same size, it looks like I could just take these screws out and the glass will come out of here. Although it also looks like they seal this edge with silicone, which makes sense. That way any liquid that spills in the stove and gets underneath here shouldn't be able to get into this unit, which would account for all of this corrosion. This is just years of spillovers on the burner working its way in here. Okay, I'm almost done. I cleaned this up some. I know I said I was going to try and remove the rest of this paint, just expose this stainless, but the problem is everything I'm trying to use to get the paint off is really scratching up this stainless. You can see this is where it's the original where the paint just came off by itself. It's nice and smooth. Here it's all almost like a brushed aluminum look. I could just continue that all around. I also wasn't able to clean in this area right here as much as I wanted to, because that would involve removing the glass. Unlike that other unit where there were two clamps you could remove and then it was still siliconed in, this is just strictly siliconed in. So it's probably a silicone adhesive. I would probably have a really hard time getting this out without and possibly breaking it, so I'm going to leave that be. This staining here is permanent. I even tried acetone to take this off, and it's not coming off. But, you know, we've been living with the ugly look of this for a while anyways. It's more important at this point just to get it working. Alright, so it's been about 6 minutes, and it's boiling water. So I'm going to say that this is a successful repair, even though it was a very unorthodox way to go about it.